Hello again, and congratulations for making the decision to learn something about the loading process in EWM today. As usual, just a quick reminder to subscribe to the channel so that you also get the chance to learn about other topics with Hendrik's tutorials in the future. With that, over to you, Hendrik.
Hello and welcome to my YouTube channel. Welcome to another tutorial about SAP EWM. My name is still Hendrik, and with this video we explore the options for the destination determination of loading tasks. With that, I think you made a good decision to start watching this video. Within the next 15 minutes, I promise that you will learn something new. I promise that you will get information that you won't get in any of the SAP help text or books. And with that, let us jump into the functional part of this tutorial right away. As mentioned before, we will be talking about the options for the destination determination of loading tasks. So we are talking about the last step that is executed for a given HU before it actually leaves the warehouse. Physically, that could be the process that you can also see on this small picture here on the bottom right. For example, a forklift loading the pallet into a truck. It can also be a case being loaded into a trailer or whatever, but the object will leave the warehouse physically and will be posted out of EWM logically. Latest with the GI posting, but the loading task itself should be the last warehouse task which is executed for the given HU. So what are we going to do within this video? First of all, I will explain some preconditions that are required to do loading at all in EWM. And once this is clarified and understood, we will look at the three main options that I could find that I am aware of. We will do a deep dive into the logic. That does not mean that there are no other options. I'm very happy if you know other options for the destination determination of a destination, and if you would explain those here in the comment section of the video, so I can also learn something here. As with many other areas of EWM, I'm pretty sure that I do not know everything, and I'm always happy to expand my knowledge here also. Having completed that main part of the video, I will also explain some hidden findings and some discoveries that I made by researching this topic. Based on the three options, there are some interesting behaviors in EWM that I wanted to give you along with these videos. And before I then close the video with a summary, as usual, I will give you some possibilities to enhance the standard logic here based on the custom requirements that you have in your projects. Let us start with the precondition, and here it is important to understand the difference between simple and complex loading. Simple loading is not more than just setting the status and the timestamp on level of delivery, or TU. TU meaning the transportation unit here. So we are loading by setting the relevant status. When we are talking about complex loading, we are talking about loading with warehouse tasks. And that implies that you are using the process-oriented storage control. It is not possible to do complex loading by definition without the POSC and without a step of the type load in your storage process. This is a screenshot from the definition of the external steps, and you need to define a storage process having the loading step, then following the picking or staging step as part of the outbound process. So keep that in mind. We are talking about a complex loading with this video here. In addition to this, I think it is important to understand how loading warehouse tasks are actually being created in EWM. And here we have in general two different options, an automatic creation and a manual creation. And to start with the automatic one, there are two main options. One of them is this tiny little flag here, which you can set in the customizing as part of your storage process. And that just means that if a given predecessor step of the loading step is completed, for example, the staging step, that with the completion of this step, you automatically create the follow-up task, so the task for the following step in your storage process. The SAP help here gives a good example for this, also tackling the loading task creation here. This is one option. The second option is a PPF action that you get from the SAP standard here, and that action is being scheduled based on a specific status of the TU, so based on a status change, and then automatically creates the loading task. So for example, all your HUs are staged already, and then when the HU arrives and is activated or is docked at the door, that automatically the loading tasks are created for those HUs which are waiting in the staging area. Kind of makes sense from process perspective, because you don't want those tasks to be showing up in the queues before the truck is actually there and the HUs can be loaded. Yeah? Then the manual options, just two examples here. There are other options that you can use to trigger it, for example, from the monitor or whatever. Here I just listed two of them. SCWM load or SCWM add HU can be used. And those transactions are basically doing the same thing in the back end. They are grabbing an HU which already has a storage process and the active step, and then just trigger the task creation, and EWM will determine the next step and the next destination based on the storage process which is saved in the HU header. This should just be some kind of an introduction. You know now which kind of loading process we are looking at. You know what is needed as a precondition, and you know how the tasks are being created. So let us look at the options for the destination determination, and let us take a deep dive into the technical part of this. We again start with the process-oriented storage control, because there is a main differentiation here based on the rules-based flag. So in general, we differentiate between a rules-based and a non-rules-based destination determination. As I said before, we need an external step of type load, and this external step is used to determine the destination of this current step. Now, this is different to other steps. For example, packing step, we determine the destination of the previous step, which would be the picking step. So if you have the storage process with picking and packing, and then you define the destination as part of your packing step in the storage process, then this is the destination for the previous step, so for the picking step. For loading, this is different. For loading, you define the destination of the loading step really as part of the loading step. So here, in this example from EWM standard best practice, we have OB04 being the loading step, and this record here is then used to define the destination for this loading step. And this can be done rules-based or non-rules-based, and as usual, the help text here, which you can call based on the F4 button, does not really help you. I will skip that. You can pause the video, read through it. You will not be smarter than before, but feel free to do that. I decided that it would not be very helpful for us, so we skip it and look into the options in detail here. And we start with a non-rules-based one, because that is pretty simple. With the non-rules-based option, you unflag this box and you give the destination of the loading step here as part of the external step itself. So in this example, the destination of the loading step for all HUs following this storage process would be the bin door _01. It's that simple, yeah? So all HUs would be confirmed and loaded to the same bin. It would actually be possible to keep the bin empty and only give the destination storage type, for example, and then define the storage type as being as allowing generic put away warehouse task, but I tested it for you and noticed that the RF dialog does not really like this. So when you define the destination storage type only, the task actually is created, but the fields will show as empty here, and you can also not use exception code to provide the destination manually. So theoretically possible, yeah, the loading task will be created, but if you want to use the standard RF dialog for the confirmation, that does not really help you. Now we come to the interesting part, the rules-based options. And for those of you who have watched the other videos about the process-oriented storage control, might be familiar with the function module SCWM storage control PGET, because this is a function module which evaluates all the rules-based determination logics for the different process step types. And with this video here, we are looking at the type loading, so the last part of the outbound storage process. And here, in case the rules-based flag is set, EWM calls function module SCWM get door tu underscore int. And this is supposed to return either a tu or a door. And we are having a quick look now into the details of this logic, which is also not too complex. The first thing that this function module does is to check whether the delivery item, so it starts with the HU, and based on the HU it selects the HU items, and the HU items have a reference to a delivery item. Based on this delivery item, EWM checks whether there is a reference to a TU, so to a transportation unit. If this is the case, the function module returns the number of this TU. If this is not the case, so the delivery item is not assigned to a TU, then the logic here tries to get the door data from the delivery item and then returns the door bin. Now I will come to this later. Every door has a door bin assigned to it, or can have a door bin assigned to it. And if this is the case, then this function module will return this door bin. So just a quick look at the interface of this function module, and you will see there's two exporting variables here. So it's either a bin, the one from the door, or it's a TU. These are the two variables relevant in the context of the destination determination for the loading step here, when we are using this function module. And the result is then carried back to the storage control PGET function module, which we saw before and which kicked off the determination initially. So this function module then has either a door or a TU or an error message. If it could neither determine a TU or a door bin, then we will end up with an error message at this point. I will come to this later. Error message means the step cannot be skipped, but let us first explore the two options a bit more in detail. You will see two examples here for those warehouse tasks. So the first one here, that is a loading task created for a delivery item which does not have any TU assignment, and here the rules-based option determined the destination bin, which is the door bin. And in the example below here, we had a TU assignment, so we have the internal and external TU number as a destination for the warehouse task, and the bin is actually empty here. Before we close the deep dive, just a quick excursus, because I think it is important to understand how the door actually got into the delivery item. Because I told you now, if there is no TU, then EWM just takes the door bin. But where does the delivery item get the door from? And for this, I would just give you a quick insight into the determination logic, which most of you probably know, because it's rather simple. We have this SCWM stay_det_out and stay_det_ass for the access sequence. And this is the determination table for the door. This is the same table that you use for the staging area determination on the outbound side. And if you look at the records, if you look at the application data here, you will see that you can use, for example, warehouse process type or HU type or staging area determination group, carrier, and so on to determine the group, area, bay, and, important for us, the warehouse door. So this determination table can be used to determine the door for the delivery item, which is then evaluated later, like I showed you now, in the context of the loading destination determination for the loading step in the POSC. And as I said before, every door can or should have a door bin assigned to it, otherwise the destination determination will not work for the door, and this door bin can be assigned via transaction SCWM door_SCU. You get a table like this, pretty simple, the door that you defined in the customizing and assign a bin here as part of the application data. And the loading task creation itself will fail if the delivery item has a door and this door does not have a bin. Only the door is not sufficient. You need a bin for the door also. And then, to sum it up, the function module returns a TU or a door, and if there is no TU and no door, or no TU and a door but no door bin, then the function module returns an error message and the loading task creation fails. It will not skip the loading step. Some of you might know that for the process-oriented storage control, I'll explain that also in some of the other videos about the POSC. For some steps, for example, value-added services, quality inspection, and so on, the step is skipped in case you marked it as rules-based and the determination could not return a result. For example, because for the quality step, there is no inspection document. Then inspection is not relevant, the step is being skipped. For the loading, this is not the case. So if it could not find the destination, the task creation fails. It is not just skipped. Then you have an error. Important to understand. Before I come to the closure and the enhancement options, just two interesting discoveries that I made while testing here, just real quick. I thought they might be interesting for you. First of all, that the destination display in the standard RF dialog, you see a screenshot here, will always be the door bin, even if the destination for the loading task is a TU. You see this row here, you see the destination of the loading task is a TU. The destination bin is empty here. This is HU890 at the end. You see that here, but still the destination bin is shown as a door, even though this is not there in the warehouse task itself. And EWM reads this from the active TU. There should be at least, there should be one active door shipping and receiving activity. You see it here, and because the TU has to be in the status arrival at door, and it can only be in the status arrival at door if there is a door assigned to the TU. And in this case, you will find one active door record here for your TU, and this active door record is also showing the door bin from the TU, from the door application data. And this is then shown as a destination in the RF dialog. So even if you determine the TU as a destination in the task. I thought that would be interesting to know. When you confirm this task, the task will be confirmed to the TU. You will not have the bin in the task. It's just for display here. But, and that's also interesting, that's the second thing that I wanted to show you, if you created a task with the door bin as the destination, for example, due to the fact that at the point in time when the loading task was created, that there was no TU assigned to the delivery item for the HU. As that means the loading task was created with the door bin as the destination, but when at the point in time when you execute and confirm the loading to this door bin, if at this point in time a TU is assigned to the delivery item, or the other way around, then the task is being updated with the TU itself as the destination. You see it here, these two screenshots, that's the same task that you see here. The task above shows the status before the confirmation. Then I assigned a TU to the delivery item and confirmed the task. And you see the destination bin is empty now, and EWM updated the task as the destination, as the TU as a destination. This is important to understand. This has nothing to do with the first finding that I showed you, where the RF displays the door bin, but in the background we still have the TU as a destination. So it seems the TU always has a priority here if it is assigned to the delivery item. And even if there was a door bin in the task before and during the confirmation, a TU is assigned, then EWM will update the task so that we have the TU in the destination. I thought that would be interesting for you to know and take away from this video. Having said that, we come to the closure. Just a very quick look at the enhancements. Basically 2 options to manipulate the behavior here. The first one is BAdI SCWM X_SR_stay dead. And this BAdI is used to influence the staging area determination. And when I'm talking about staging area determination, I'm also talking about door determination. Now ignore the term staging area here. This is just being used to manipulate or integrate a custom logic for the determination of the door on the delivery item. And you learned before that the door is one option for the loading task destination. So that means with this BAdI, you can also influence then the loading task creation, which is being executed at a later stage of the process. Now the door is being determined earlier already, usually. Second option, and again, for those of you who have seen the other tutorials on my channel for the process-oriented storage control, there is a BAdI that is being called at the end of this function module storage control pget. And with this BAdI, you can basically overrule and overwrite whatever is being returned from the standard logic, either the bin or the TU, whatever you would like to change. And this is independent from the process step and can be used also for the loading. With that, we are already at a point where I would like to close this video. A very quick summary for the options for the destination determination of the loading task. You learned that you need the process-oriented storage control to execute the complex loading. You learned that the task can be created automatically with the POSC or with the PPF action. It can also be created manually, for example, with SCWM load, and that the destination can be based on 3 different options, at least based on my current state of knowledge. And the first one is a fixed destination based on the bin given in the external step data of the POSC customizing, non-rules based. And then there's a rules-based option, either the TU, which is currently assigned to the delivery item, or a door, which is given on item level, and then the door bin as destination in the task. Now there is no option to skip this step, so if those 3 do not return any result, so the non-rules based or the rules based, then we will get an error message. It's not foreseen to skip this step. With that, I thank you a lot for your attention. I'm always happy if people use my videos to expand their knowledge. I would be even more happier if you show your satisfaction by just hitting the subscribe button here for my channel, because that motivates me for creating additional videos. Feel free to get the content in detail, including a lot of screenshots and all the technical details from my blog on WMexperts.online. And with that, I would be happy to see you again for the next tutorial. Until then, I wish you happy learning and a good time. Bye bye.